Not much different than the other ones, except for it involves just slightly more algebra because of the way that the side length is labeled, and that's going to be this one, b plus 3. But other than that, everything else is pretty much done the same. As we set up a proportion, you look at the three different triangles that are formed, the small, the medium, and then the large, and identify which parts of which triangles you know. If I look at the large triangle, the only thing that I could really the only thing I'm knowledgeable about is the hypotenuse, which would be 8 plus b plus 3. I don't know either leg, so I'm not going to use that triangle. I do have enough information in the small triangle and the medium triangle to set up proportions, which within those triangles I know the short leg of both of them and I know the long leg of both of them. So that's why I'm setting up the proportion the way that I've got it listed here. So if I look at the small triangle, the short leg of that small triangle is b plus 3. So I'm going to put that here as the numerator of that first ratio. The long leg within that small triangle is 6. And then if I look at the medium triangle, this one over here on the left, I've got a short leg of 6 and a long leg of 8. And that's enough for me to now set up an algebraic equation. So I'd cross multiply and say that 8 times the b plus 3 is the same as 6 times 6. Okay, and now I work through the algebra of that. I'm going to distribute this 8. So 8b plus 24 equals 36. I would subtract away 24 from both sides, so I've got 8b equals 12. And now to get b by itself, I would divide both sides by 8. So b equals 12 eighths, and when I simplify by dividing 4 from the numerator and denominator, b would equal 3 halves, or 1 1/2. Okay, so that is the only value that I could possibly have in order for this to be true, where these are all right triangles.